Hello everyone, welcome back. Um, let's start today with a question, a very popular question in MYP, IGCSE, GCSE, or IB Diploma, SL, HL, all the exams. So here is a question. Solve the following equation for x between negative 2 pi and 2 pi. And this is your question. So obviously when sine x is 1 by 2, x will be arc sine or sine inverse of 1 upon 2, that is pi by 6 or 30 degree, right? So this is your answer. But if you closely look at the domain, the given domain is negative 2 pi to plus 2 pi. And when you look at the graph of it, this is graph of y is equal to sine x. And if you look at the equation which reads sine x is equal to 1 upon 2. So to solve this equation graphically, what we can do, one possible method is you just draw sine x and then you draw y is equal to 1 upon 2 and check point of intersection. So if you draw y is equal to 1 upon 2, we can see in this given domain, that is negative 2 pi to plus 2 pi, there are 4 points of intersection. This is your first point of intersection, this is your second point of intersection, this is your third point of intersection, and this is your fourth point of intersection. It means for sine x is equal to 1 upon 2, between negative 2 pi and 2 pi, there must be 4 answers. And what we are getting here is only one answer. So what are other 3 answers? How do we find? We know the periodic nature of the sine function. Even if you have cosine or tangent, we see that values get repeated. Values of angle for which the trigonometric ratio is same, we can have multiple values. So in today's video, we will explore how to get those multiple values. Before that, I would like you all to recall certain things. Number one, positive. A positive direction is an anti-clockwise direction. So even in sciences, in physics and in other natural sciences, a positive direction means anti-clockwise direction, and a negative direction is always a clockwise direction. So when we talk about negative, we are talking about clockwise, positive means anti-clockwise. Also, you should be very comfortable in moving between radian measure and degree measure. So recall that 180 degree is pi radian. Okay. Also recall, if you divide angles around a point, that is 360 degree, into 4 parts, each part is called quadrant. We start from 0 to 90 or 0 to pi by 2, then pi or 180 degree, 270 or 3 pi by 2, and 360 or 2 pi. And if we continue moving 0, 180, 360, 180 more, that is 540, 720, and so on and so forth. Between 0 and 90 degree, this quadrant is called first quadrant. In this quadrant, all trigonometric ratios are positive, whether it's sine, cosine, tangent. For HL, their reciprocals, they all are constant. Between 90 and 180, we call second quadrant, and in the second quadrant, only sine function is positive. 180 to 270 is called third quadrant, and in this quadrant, only tangent is positive. And in the fourth quadrant, that is 270 to 360 or 3 pi by 2 to 2 pi, we have only cosine positive, right? So this is really important that you should remember all sine, tan, and cos. There are multiple ways to memorize. One popular way is ASTC. So add sugar to coffee. This is one of the ways. You may use anything that suits you, but the bottom line is you must memorize this, right? Let's move on. If you revisit these quadrants, you see something really special here. So this is your quadrant system. In the first quadrant, all are positive. Second, only sine. Third, only tangent. And in the fourth quadrant, only cosine is positive. Now remember, we are working anti-clockwise. That is, we are talking about positive angles. So we start from here, 0 degree or 0 radian, you go all the way. When you come to other side, it is pi radian. You continue working, 2 pi radian. Continue moving, 3 pi. Next will be 4 pi. Next will be 5 pi, 6 pi, and so on, so forth. Now, out here you have pi, 3 pi, 5 pi. If you would like to come to the second quadrant, then your value has to be less than this value, isn't it? Because this is 180 or pi. If your value is more than pi, it will jump to the next quadrant. So to remain in the second quadrant, your value, the angle has to be less than this pi, or less than 3 pi, or less than 5 pi. We are assuming that angle is an acute angle, but practically any calculator value will be used here. So out here in the second quadrant, what kind of angles do you get? You get pi minus theta, 3 pi minus theta, 5 pi minus theta, and so on, so forth. If an angle is more than pi, it will come to the third quadrant, assuming theta is acute. So in the third quadrant, you will have pi plus theta, 3 pi plus theta, 5 pi plus theta, and so on, so forth. Right? Moving forward, in the fourth quadrant, you have 0, 2 pi, 4 pi. So it has to be 2 pi minus theta, 4 pi minus theta, 6 pi minus theta, and so on and so forth. And when you go back to the first quadrant, we are assuming the first value is the calculator value, which is an acute angle. Practically any angle you have, we will follow the same rule. So next value is going to be 2 pi plus that value. Next will be 4 pi plus that value, and so on so forth. So first thing to remember is, if your angle is made in the second quadrant, it has to take this form: 2 pi, pi minus theta, 3 pi minus theta, 5 pi minus theta, and so on so forth. If your angle is formed in the third quadrant, it has to be pi plus 3 pi plus. Fourth quadrant, 2 pi minus 4 pi minus, and so on so forth. Right? Now, coming back to our question, sine theta is equal to 1 upon 2. So one value of theta is sine inverse 1 upon 2, that is pi by 6. How about other angles that give the same value for sine theta? So for this, remember one more thing. Where is sine positive? Sine is positive in the top layer, that is first quadrant and the second quadrant. One value is theta. So next value is going to be pi minus theta. Next value will be 2 pi plus theta. Next will be 3 pi minus theta. Next will be 4 pi plus theta, and so on so forth. So this is how values are repeated in sine when we are talking about positive angles. Remember, we are still moving in positive direction. When it comes to cosine, cos, what do we get for cos? Angles that give the same value for cos. Where is cos positive? First quadrant and the fourth quadrant. So cos is positive out here. And how angles behave in these two quadrants? One value is theta. Second will be 2 pi minus theta. Third will be 2 pi plus theta. 4 pi minus theta. 4 pi plus theta, and so on and so forth. So this is how values of cos are repeated. And when it comes to tangent, tangent is positive in first quadrant and third quadrant. So values will be theta, pi plus theta, 2 pi plus theta, 3 pi plus theta, 4 pi plus theta, 5 pi plus theta, and so on and so forth. So this is how we can find multiple values of theta when theta is positive, right? Let's move on and further explore when angle is negative. So for negative angles, when we are moving clockwise, right? So when we are moving clockwise, how will this look like? So remember, now you're starting from here and going in this direction. So first angle will be here, 0. Now we get pi here, but since we are moving clockwise, so what do we get? Negative pi. Keep moving. Next will be negative 2 pi. Next will be negative 3 pi, and so on, so forth, when we move in the negative direction, right? Sine, cosine, tangent, their properties remain same in these quadrants. That is, sine is positive in first and second. We are still considering this is first, this is second, this is third, this is fourth quadrant. So when you come here, remember that you are moving clockwise now, right? So you come here clockwise. On this line we are negative pi. So to come to second quadrant, what will your angle be now? This will be negative pi plus theta. Negative of pi plus theta, negative of 3 pi plus theta, negative of 5 pi plus theta, and so on, so forth. For this one, it will be negative pi minus theta, negative of pi minus theta, negative of 3 pi minus theta, negative 5 pi minus theta, because we are moving clockwise, remember. For the next quadrant, it is going to be negative of 2 pi minus theta, negative of 4 pi minus theta, and so on and so forth. And for this fourth quadrant, this is going to be negative of 2 pi plus theta, negative of 4 pi plus theta, and so on and so forth. So same way, sorry, when we explore for sine theta is positive in these two quadrants. So how your angles will look like? Theta, negative pi plus theta, negative 3 pi plus theta, negative 5 pi plus theta, negative of 2 pi minus theta, negative of 4 pi minus theta, and so on and so forth, right? So these are the values that you get for sine. Similarly, for cosine, take these two quadrants. So in these two quadrants, values are theta, negative of 2 pi minus theta, negative of 2 pi plus theta, and so on and so forth. And similarly, for the tangent, which is positive in these two quadrants, so it is going to be theta, negative pi minus theta, negative 2 pi minus theta, negative 3 pi plus minus theta, and so on and so forth. Right? So this is how sine, cosine, tangent, they behave in different quadrants for multiple values, whether it is positive or negative. Right? So let's go back and revisit our question. The question, sine x is equal to 1 upon 2. So when sine x is 1 upon 2, x is equal to sine inverse of 1 upon 2, that is pi by 6. Right? So this was one value. Now, when values are repeated, how do we get other values? Let us explore. X is pi by 6. Other values will be when you move anti-clockwise. So for second quadrant, it will be pi minus pi by 6. Keep moving. For first quadrant, 2 pi plus pi by 6. Now we are already more than 2 pi, so we may stop here. And when you move in the negative direction, first angle will be negative of pi plus pi by 6. That first quadrant, negative of 2 pi minus pi by 6. And the third value will be 3 pi. So again, we are going beyond this domain value, so we may stop. When you simplify, you see 2 pi plus pi by 6 is still beyond 2 pi. So you may ignore it. So you have 4 values: pi upon 6, pi minus pi by 6, negative of pi plus pi by 6, and negative of 2 pi minus pi by 6. So these are 4 values. Do you remember there were 4 points of intersection? Here are 4 values. So this is how we work with trigonometric equations when you have multiple solutions. You usually have multiple solutions, and this is how we find multiple solutions. So that's all for today. If you found this video helpful, please like it, subscribe it, share it, and don't forget to press bell icon so that you are the first person to get the notification when a new video is posted, right? So take good care till we meet again.